Unlocking the mysteries of the distribution curve. Hello, everyone. Welcome back to our channel. Today, we're diving into an interesting topic that you might have heard of, the distribution curve. Whether you're a student, a professional, or just someone curious about English language nuances and scientific terms, understanding this concept is incredibly useful. So, let's unravel the mysteries of the distribution curve together and make it as simple as possible. A distribution curve is a graphical representation that shows how data points are spread across a range. Imagine you have a bunch of numbers or measurements, and you want to see how they are distributed. This is where a distribution curve comes in handy. It's often shaped like a bell, which is why you might hear it called a bell curve in some contexts, especially when talking about normal distribution. Not all distribution curves look the same. They can vary greatly depending on the data they represent. Here are a few types you should know about. Normal distribution. This is the classic bell curve, where most data points cluster around the middle and fewer are found as you move away from the center. Skewed distribution. Sometimes, data isn't evenly spread out. If there are more data points on one side of the curve, it's called skewed. It can be left skewed or right skewed, depending on which direction the tail is longer. Bimodal distribution. This type of curve has two peaks instead of one, showing that there are two dominant groups within the dataset. Distribution curves are not just academic exercises, they have real-world applications. For instance, they can help in assessing student performance. Understanding how grades are distributed across a class can help teachers identify the most common outcomes and adjust their teaching strategies accordingly. Business forecasting. Companies use distribution curves to predict future sales, customer behaviors, and market trends. Scientific research. Researchers apply these curves to analyze experimental data and draw conclusions about natural phenomena. Reading a distribution curve is crucial for interpreting the data correctly. Here's what to look for. The peak of the curve shows where the most data points are concentrated. The spread of the curve indicates the variability of the data. A wider curve means more variation. Tails of the curve tell you about the outliers or extreme values in the dataset. Understanding these elements can help you grasp the overall shape and implications of the data you're dealing with. And there you have it, a simple guide to understanding distribution curves. We hope this video has shed some light on this fascinating topic and that you can now appreciate the beauty and utility of distribution curves in various fields. Remember, whether it's in language learning, science, or business, mastering these concepts can provide you with valuable insights into the world around us. Thank you for watching, and don't forget to like, share, and subscribe for more content like this. See you in our next video.